Very good. Thank you, Chris. Good evening, everyone. Welcome to the February general meeting of the Fort Worth Astronomical Society. I'm glad so many
I
people.
mean, they're connected, but I can't get them through here.
Oh. So.
Only screen I've got is
I was just putting those on because they were better.
Everybody's going to want to mute their microphones, please.
So I'd like to welcome everyone to the February meeting. I perused the list of people who have joined, and I saw some names I haven't seen in a while. So welcome back. I think it's just wonderful that you've joined us tonight. We thought we were going to have more frozen precip than what has happened. But out here in just west of Fort Worth, my mailbox is iced over, but not the roads. So I think we did the right thing by moving this to virtual only, and I think it'll be a great experience. We did have to cut through some problems getting things up and running, but I think we have everything under control right now. So let's go to the next slide. I guess that's me. Next slide. There we go. So this is the slide where we invite our visitors to, or we welcome our visitors to the meetings. But in this particular case, I just pleased that you've joined us virtually, and I hope you find time to visit us in person at a future meeting. And if you need details about the meeting in terms of the location and or the topic, please refer to our members webpage at fortworthastro.com, and you'll find the information you need. However, if you do have questions, you can email us at info@fortworthastro.com, and we'll provide you more information about the location and how to find a room within the facility. We do hope that you find the club satisfies your astronomy needs, because looking at the night sky gives you license to leave the world behind, because you'll find that once you're outside looking at the stars, the planets, and other celestial objects, there's a different kind of peace that takes over. So let's go to the next slide. So we do have a variety of members, or a list of members who joined the club since we've last met. And I know that there are at least 3 of these folks from the Cross Plains area. So I welcome you. I would also like for you to take the opportunity to come join us at an upcoming in-person meeting. It'd be nice to put a face to the person, as well as get to know you and share some experiences. So next slide. And so what about fortworthastro.com? It's kind of interesting that we were founded in 1949, and we're one of the oldest astronomy clubs in the United States. If you did a count of all the people that are in the club, we have 392 actual people in the club, but just over 200 and I think it's like 220 memberships, which is good for the club. The club continues to grow. You'll find that the club members are made up of a wide variety of people that like various things in astronomy, and anywhere from radio astronomy to just visual astronomy to astrophotography in a very big way. So I think we might have some people who you'll have good relationships with as you move down your path of astronomy. And that goes to that nearly all of our members are willing to help you with any questions or any issues that you might have in your astronomy journey. So just need to reach out via our e-group, our email forum we'll talk about later, and you'll get fairly prompt answers on to your questions. And least but not last is we're a nonprofit organization, so we're willing to accept your donations if you're so inclined. So now that the new members have joined the club, there are a number of resources that you'll have access to. We have a couple of observing areas you can go to. Those that are from slightly dark at the Thompson Observatory in Keene, Texas, to our Rising Star observing area that's outside of Cross Plains. And we're in Bortle 2 skies, which makes it great for observing stars, constellations, and most deep sky objects. We do have club telescopes, eyepieces, and mounts that are available for your use and for checkout, in case you want to give them a test run before you make that purchase of yours. We also have a membership handbook that guides you through the rules and regs of our club to make sure that you understand how things are done, and so everyone can get along smoothly. And then we do have a number of online resources, including these on this page. Our fortworthastro.com page, which covers everything from our history to joining the club to where we meet on our regular meetings. We do have a Facebook page that has a number of, I think we have 3,000 people who follow us right now, as well as YouTube, where we have just a number of good meetings that are posted, about a year's worth. And the presentations have all been very interesting, as well as the Q&A after those meetings. And then the last two items that we offer are the Groups IO, or our main discussion forums, as well as our Astrophotography Special Interest Group, or APIGSIC, where people who focus more on astrophotography get together and talk about what works, but more often what doesn't work, and some of the good astrophotography pictures that we've taken. So Bill, I'd like to turn it over to you so you can introduce our speaker, and so she can talk about this fascinating topic.
You got it. Thank you, Bruce. So tonight we've got Dr. Sarah Sutton. She's an engineer. She's worked in research and development, and she's a scientist involved with the imaging team for the Europa Clipper mission, which is currently on its way to Jupiter to image Europa and study Europa, ultimately with the goal of verifying that the moon's got an ocean, and possibly paving the way for future missions to look for life. So, Sarah, it's all yours.
Hi, okay, so can everybody hear me okay?
Yes.
Okay, great.
Yes.
Thanks for the introduction, and thanks for inviting me to give a talk to your group. It's probably a good thing I didn't actually go to Texas because it sounds like you all didn't get to go to your meeting in person tonight anyway either. Sorry about your bad weather. I am not an astronomer. I just have to tell you, as an astronomy society, that don't ask me about telescopes. I probably won't be able to give smart answers to questions about astronomy. But I am here to talk about Europa Clippers. So if I could share my screen, I will put up my slides. I cannot share the screen because somebody else is sharing.
Okay, so let me stop sharing.
Okay, thanks.
You're on.
All right. I do live in a dark skies county, and astronomy is very big here at the University of Arizona, where I work and have spent a lot of my career. So I appreciate, and I'm surrounded by people with telescopes and great astronomy facilities. And so when I get to look through telescopes, super excited. But in general, it's not what I get to look through. All right, so I'm at the Lunar and Planetary Lab at the University of Arizona. Europa Clipper is a mission run out of JPL, and the camera instrument called the Europa Imaging System that I work on is run out of the Applied Physics Lab at Johns Hopkins University in Maryland. So we're a multi-institutional group international, it's NASA, there's ESA collaborations. And so I'm not sure how much you all know about this. This is just going to be sort of a general overview about Europa Clipper. But I would like to start with a video, and if it doesn't play, that's okay, we'll just skip it. I mean, if you can't hear the sound, this is a video though that really says better than anything I could say why going to Europa is so important and so exciting. It really talks about the motivations of the mission. And it's given by Bob Papalardo, who is our project scientist at JPL. And he has advocated for this mission for decades. And it has taken decades and like huge amounts of work to make it happen. And the other person that is speaking on this video, I unfortunately never got to meet her. I think she was the project scientist for Galileo, which flew to Jupiter and took fantastic images of the moons. And unfortunately, I think she has passed away. So let's try playing this.
Hey, Sarah, you're not in
Yes,
presentation mode.
I'm not.
Yeah,
Again?
again.
Sorry about that. So
That's
what do you
okay.
see? My presentation screen?
Yeah, like your current slide and then what you got coming up.
Nope. I thought I fixed this. All right, let me try again.
That's all right.
Yay.
Technical difficulties is the theme tonight. So there you go.
Now I'm in. Oh, okay. It did switch because earlier we did the same thing. All right, so great. That's the slide, the title slide. Here's the video. I'm going to try to play the video. So tell me if you don't hear sound. Is it going to play? Wow. Doggone it. There. Nope. I am sorry for that. All right, I'm going to get out of sharing because that seems to be the issue. And I will just find the video because it's really nice. And if I don't find it, that's okay. Actually, I'm going to skip it because I think we're all tired of my technical difficulties. All right, I have a feeling I'm going to get this wrong again. Do you see the Alien Ocean NASA's mission to Jupiter slide?
Yes.
Yes.
The video that won't play now?
Yeah, but it's a great graphic.
It's lovely. And the message that Bob conveys so eloquently that I will try to convey is that the reason we want to go to Europa, to Jupiter, but we're specifically focusing on Europa, is that it's a world that is like Earth's moon in terms of its size. But when Galileo visited the Jupiter system in the 90s, we could see that it was very different. It's covered, instead of with craters, it's covered with ice. And that ice is not covered with craters, which indicates that it's changing all the time. But so you have a completely ice-covered moon with these long linear features, cracks and ridges. And the idea is that if there's a subsurface ocean there, which we're pretty sure there is, and you have this environment where you have tidal heating, which I'm going to talk about more later, and you have an ice surface that's fresh because it's not bombarded with craters, which would indicate an old surface, then something is active. There's active processes inside of this moon. So if you have heat and you have water, you have the ingredients for life as far as we know. And so our goal is not to discover life at Europa, but to go determine, is it possible that it contains the environment where life could exist? And if it does, that would mean that there would be life within, like under the ice crust, so protected from this intense radiation environment of Jupiter. And Bob ends with this fantastic kind of goosebump statement that like if life could form in Europa, it wouldn't be that hard for it to form in other places in the solar system. So I have to kind of think about this because I'm not an astrobiologist either. I'm a geologist. So I like rocks. But when I draw back and I look at the big picture of why we're going to Europa and how important this is, it is like the most important question. All right, that's me trying to paraphrase what would have been in that video. Okay, so here's an overview, and tell me again if you're not seeing my presentation slides. All right, the Galilean satellites of Jupiter were discovered by Galileo. These little cartoon stars and circles, this is actually what Galileo observed in his telescope, as I'm sure you all know the story. And what he saw were these little stars changing their position relative to the planet Jupiter over a series of nights. That turned out to be these 4 largest moons at Jupiter: Callisto, Ganymede, Europa, and Io. They're all quite different, but Callisto, Ganymede, and Europa are all considered these ocean worlds covered in icy or icy rocky crusts and possibly all harboring subsurface oceans. Io, completely different, has no water, is incredibly volcanically active, and is interesting for all kinds of other reasons. All right. So the last time the Jupiter system was visited by a long duration mission was the Galileo spacecraft in the late 90s through 2003. I was not part of the planetary science community at that time, but I love to hear stories of the people who got to be on that mission because it sounds like it was super exciting. And these are some of the images they took of Europa. So to give you an idea of up close, like why is Europa so weird and exciting? So this is an example of the ridged plains. It looks really different. Again, like I said, it looks really different than Earth's moon. The surface is covered with cracks, ridges, ridges that can extend and expand for thousands of kilometers across the surface. So this tells us as geologists that this surface is very active. It's constantly changing. Why is it changing? Well, that's one of the reasons we're going there, is to sort of figure this out. So there's also these areas that look like broken up icebergs on Earth, except there's no water between them. They're just these sort of broken up, fractured chunks that look like they've separated and filled in with other things. So they think these are locations that actually have broken apart, rotated, tilted, and then frozen into new positions. So what caused that to happen? There's also these strange dark features called lenticulae, or sometimes they just call them pits or spots or domes. Again, we're not really sure what these are or what these reddish colors are that we notice in the surface. It's water ice, but there's these different tones, like these reddish colors, that we're not sure what those are. Then we have these bands, these like wide swaths of banded material that clearly, well, maybe not clearly, but it has been shown that the material on either side, if you took out that band part and then pushed the pieces back together, it's kind of like tectonic plate movement on Earth, where you can reconnect the features across these. So then some other process has injected material up into the surface and spread apart these older surface ice features. So lots of interesting stuff going on the surface geologically. And again, these are all Galileo images. Here's a wider view of more complicated ridges, bands, chaos terrain. It's a very interesting place. And also, I don't know if you all want to jump in with questions. I cannot see the chat, so maybe we save questions till the end. But if you do have a question that you really must know, don't hesitate to ask while I'm talking. So I mentioned earlier that there's not a lot of craters or no craters, but there are a few craters on Europa's surface. So the way we determine the relative age of a planetary surface in our solar system is how many craters does it have on it? The moon is our kind of Rosetta Stone, so to speak, of crater chronology. Because we have samples from the surface of the moon that we can date with words like radiometric techniques to understand the radioactive decay of certain elements. You can actually put a geologic age on materials. So we do this on Earth all the time, and when we can do it from a location where we've pulled a sample from the moon and brought it back to Earth, then we can start to put actual numbers on how old is the surface. So the Apollo astronauts brought back lunar samples from specific locations, and then we look at the crater sizes and frequencies on the surface of the moon, and from that they sort of came up with this crater surface chronology. That's great for the inner solar system because we're inside the asteroid belt. So we have this assumption about the flux of impactors over time that are coming into the inner solar system from the outer solar system and mostly from the asteroid belt. A lot of that is actually thanks to Jupiter, which is outside of the asteroid belt. So what is the crater? How do we calibrate our crater impact flux in the outer solar system? This is not my area of expertise, but I can assure you that people do study this, and you don't even have to understand the nuances, all of that. What you can see, though, looking at the surface, is that there are very few impact craters. I think there's like 3 that are of like really visible. Maybe we'll discover more with Europa Clipper because we're going to get such great coverage and resolution, but they will be much smaller. And so it sort of scales that there are fewer larger impactors over time and maybe more smaller ones. There's no atmosphere on Europa to break up any sort of impactors, so we don't have to contend with that factor. But here is one of the craters on Europa. Very obvious. It has bright rays, which might indicate that it's relatively fresh in a geologic sense. Its name is Welsh. I will try to pronounce it. I think I've heard it pronounced Pwyll, which is spelled Pwyll. We have an Irish team member and she assured us that's how it's pronounced. I'm still probably mispronouncing it. So what do craters do on the moon and on Earth? Well, they create these big bowls with ejecta that comes out and gets sprayed out around the craters. On icy structures, they tend to change over time in a different way than when they're impacted into rock. So here are 4 of the known craters on Europa, and there's Pwyll, and it has an uplifted center material. So that's interesting. And then here's Silix, which has dark ejecta relatively. And then I don't know how to pronounce this, Mananan. It's another Gaelic name, I think. It's almost totally flat. Like, where did the bowl go? Well, ice tends to relax more rapidly than rock would over time. And then this is Tyre, and it's multi-ring, so this is much larger. But you can see this ridge thing crossing the rings of this impact structure, which means that it's relatively older than whatever caused the ridges to happen. So here's a schematic of what Europa looks like. We believe it has a metallic core, just like Earth, just like our moon, and then a rocky mantle, and then an ocean, and then an ice crust. And I saw there was a chat. I cannot see the question though. So the features of the active ice surface and the measurements from Galileo lead us to believe that there is a large global subsurface ocean on Europa. We know from gravity measurements that there's a layer on the surface that's about 100 kilometers thick, made up of solid ice and salty water. And then the rocky mantle and metallic core, well, it's possible that there's actually geologic activity at the base of the ocean, just like we have the ocean oceanic crust interface, and there's hydrothermal activity and volcanic activity that actually supports life at the base of our oceans. And next slide. How much ocean? Well, I love this graphic because apparently there is more water on Europa and its oceans than all of Earth's oceans. That's kind of mind-boggling because Europa is the size of our moon. Mars is larger than our moon, but smaller than Earth and has no liquid oceans, a lot of frozen water. Maybe life existed there in the past, but we haven't seen any evidence of current life there today. We have seen evidence for previous habitable environments on Mars. So Europa is a big question mark. Does it have conditions today that could support life? So I mentioned tidal heating before as a source of energy that could create heat. So this is a very small body like our moon, and yet the rotation of Europa, Jupiter, and Ganymede create this resonance where every couple of orbits of Ganymede, Europa orbits, it's either 2 to 4 or 1 to 2, I can't remember. But it basically, they all line up, which creates a stretching, just like we have tides on Earth. Because of the moon's orbit around Earth, it creates gravity tides on the whole planet and flexes the planet. And Io actually experiences this even more. So we think there's not enough solar energy at Jupiter to keep the ocean liquid on Europa, but it's this tidal heating that actually generates quite a lot of heat in the interior that creates enough geothermal heat flux that will keep its ocean liquid and not be just a solid ball of ice. So the schematic, and this is a big unknown exactly, but this is what the pieces of evidence are leading to thoughts that this is kind of the structure of what the crust might be like, that you have a liquid ocean below a crust that has ice that may be convecting, just like our mantle, rocky mantle in the Earth convects slowly over time. And that there may be ways for the ocean water to reach the surface and spray out in these plumes that would eject material from the liquid ocean out into space, as they observed at Saturn's moon Enceladus with the Cassini mission. They have possibly observed this at Europa from the Hubble Space Telescope, and it is one of the lines of evidence that actually really motivated this mission. So what we're going to do now is look again at the surface and to the current best resolution images of one small part of Europa called the Connemara chaos. It's an iceberg-like region in Europa's surface. And if we zoom in, we're going to zoom in basically from like Voyager to Galileo scale imaging. And this is just a preview, like how much better even this will be when we are at Europa with Europa Clipper and the ICE cameras. ICE, by the way, is a clever pun because I believe EIS is ice in German. Oops. So we're zooming in, we're zooming in. All right, and now we're like looking at the close-up, and then it gets even closer. And I think at the best, the resolution of the very best, very like smallest coverage, but the best resolution Galileo was able to get was 6 meters per pixel, which I believe is about 19 feet. We're going to get down to 1 meter per pixel at the highest resolution with Europa Clipper, and we're going to get a lot of like 80% or more global coverage at, moderate resolution. And we're going to be able to resolve topography. So these are large cliffs, basically, if, compared to human scale, but pretty dramatic topography. By the way, I'm all about topography because that is mainly what I do for various different planetary surfaces. So that is one of my main jobs on the ICE team, is to generate the topography of these terrains with the images. So if I get a little excited about this, that's why. It's a pretty bizarre surface. Okay. So that's the full mosaic without the animation. Actually, this mosaic, they resampled it to 12 meters per pixel because there was a mix of high and low resolution images, but lots of energy to break up ice like that. So this chaos, which is what we were just looking at, and here's a schematic, like cartoon or artist rendition of how this might form, is that convective heating from below would result in like a shallow subsurface lens of melted ice or ice water mixture, and that would kind of cause a collapse feature and then refreeze. And I'm really sorry, I can see that there's chats, but I cannot actually see the chat. So I talked about ingredients for life, and that there's a lot more water on Europa than Earth's oceans, and that there also may be this subsurface heat source, like chemical energy. On Earth, we have these things at the mid-ocean ridges where we have mantle convection bringing lava up or magma up to the surface of the ocean floor. And that creates these hydrothermal vents called black smokers on Earth. You've probably seen videos. I actually have a video, but I'm doubtful it's actually going to play. I'll try though. But we know that on Earth, sunlight does not reach these locations, so they're fully like chemotrophic life forms that live there that aren't relying on photosynthesis or the rain cycle or anything. So they have a whole different like life cycle at the base of our oceans. And so in our like wildest imaginings, I think this is not actually unrealistic to think that the same thing could exist on Europa. Has this been going on for 4 billion years? That's a good question, but it's certainly possible that it's occurring now. We are not going to see to the ocean floor with Europa Clipper, but we do have some ice penetrating radar instrument that I will talk about. Okay, the video is playing. I hope you can hear it. Okay. She's
we can
talking
see.
about the depth of the ocean and that it's like 300 degrees Celsius water, and then you can see the life forms. So it's narrated and there's music, but we don't need to actually play the whole thing. It's quite long, but that's the idea. All right, so the Europa Clipper, that's enough about Europa science, at least in the big overview, but Europa Clipper, what is the mission? As I said, its goal is to explore Europa and investigate its habitability. We are not a life detecting mission. We don't have that kind of instrumentation, but what we're looking for is signs of habitable environments as a precursor to perhaps a lander in the future that would actually probably carry instrumentation that would look for signs of biological life. That's pretty exciting to think about. The top level science is habitability, and the major objectives are also to study the Europa's ice shell and ocean, its composition and its geology, and to look for recent or ongoing activity, and to perform reconnaissance for a potential future landed mission. And this lower left slide is a composite of the Hubble telescope. And I don't remember, I think it's UV, but I'm not a UV spectroscopist, so I probably will not say too much about that. But I believe it's the UV instrument on Hubble that observed this bloom, and they've overlaid this image of like map projected image of Europa so that to orient like where this might have been ejecting from. This is the instrument package on Europa. It's a flagship class mission, and so it has 5 remote sensing instruments and 5 what they call in situ instruments. So remote sensing are observing or passive sensors, and the in situ instruments are actually measuring the environment of the spacecraft, like sampling or measuring the actual plasma and electromagnetic environment. So we have the Europa UVS, which is a UV spectrograph, ICE, which I am on, and that's a narrow and a wide angle camera. So 2 cameras, narrow and wide angle, and they can map in 3D, and they have 7 color bands, 7 filters from the visible into the near infrared. So we will have color and stereo. So we'll be able to get topographic maps of the surface. MISE is an infrared spectrometer. So ICE is not a spectrometer, although it does have 7 color filters there. It's not considered a spectrometer. So MISE would be able to measure chemical composition. ETHEMIS is a thermal imager. REASON is the ice penetrating radar. I think so. All of these remote sensing instruments work together to supplement each other's science, and it's a really great collaborative package. Mass specs is a mass spectrometer, so it will actually sample the composition of any material like in the environment around Europa as we fly through it. SUDA looks for dust, or will actually sample dust and surface if any, if we can fly through a plume, that would be exciting. ECM is a magnetometer, and so the magnetometer can actually measure the electrical conductivity of the ocean properties, and it will help us understand the salinity, the thickness of the crust, and the interior structure. PIMS looks at the plasma environment. I can't really speak to that because that's way outside of my field of expertise. And then the whole spacecraft acts as a gravity and radio science experiment in terms of its orbiting in the Jupiter system, and then the radio signals back and forth communicating. Okay, Europa Imaging System is the camera system that I work on, and here's a CAD model on the left with the NAC, narrow angle camera, and the WAC, wide angle camera. The NAC can gimbal in 2 directions, so it can point and target different areas on the surface in high resolution. And here's a picture of it on the spacecraft. This silver blanketed thing is the NAC, and this little box up here is the WAC. So lots of spaghetti of cables and wrapping. They actually had a camera on the high bay in JPL where you could watch the whole thing being assembled live, like streaming all the time. So that was always on our TV at work. All right, so here's a overview global map of Europa, just showing some coverage. It's probably pretty hard to interpret that, but basically it's giving an idea of how we'll be able to cover the whole surface of Europa at different resolutions. So down to better than 10 meters resolution in some very selected areas of Europa. And then the pink is not even on here, but then a large portion of Europa better than 100 meters per pixel. So much orders of magnitude better than Galileo though Galileo was fantastic. And then this is a schematic of how we'll acquire stereo topography imaging on the same orbit, because our wide angle camera is wide angle. So it allows us to do 3-line stereo in a push broom mode. And here is a diagram of the spacecraft. It is quite large. So they assembled the spacecraft at JPL in California, in Pasadena. Then they shipped it to Kennedy Space Center, and the solar panels were so large, they actually did not assemble them onto the spacecraft until they were at Kennedy Space Center. So that was pretty exciting. And then there's other components here, the engines, the high gain antenna, which will transmit all the data back to Earth. These are the radar antennas that are actually attached to the solar panels. And you're probably, I don't know, because you're astronomers and you know a lot about space science, you're probably going, why are we using solar panels at Jupiter? That is a long history of, for reasons why we are not able to use like a radioisotope engines. Like we can't use nuclear power in the spacecraft like we used on Cassini, for a lot of reasons having to do with Department of Energy and some other laws. So we have these enormous solar panels that are like 100 feet across and larger than a basketball court. And that kind of gives me my other job, which is measuring spacecraft jitter in the push broom images. And so we know that's going to be an issue. Okay, and the launch mass was, here's a factoid, 12,800 pounds or 5,800 kilograms. The Europa Clipper is also in this, flying through this incredibly strong magnetic field, radiation field of, well, the magnetic field of Jupiter creates this radiation environment. So it's like this giant plasma torus. And so we don't actually want to spend a lot of time in that environment. So we have this complicated orbit trajectory over the tour lifespan to keep us out of that as much as possible, because of those radiation, that radiation environment will eventually fry all the instruments. So we fly in and out of the plane of Europa's orbit like 49 times. And this is just a close-up of the closest approach trajectories. So we cover both the anti-Jovian and the sub-Jovian sides of Europa about, evenly pole to pole, and a lot of flybys that come very close to the equator. So we try to maximize coverage of the surface with these flyby trajectories, and then also minimize our total radiation dose exposure. Here's a nice animation of what this looks like in 3D. And so it gives us more than 90% coverage of Europa's surface with relatively high resolution data. This I will not play all the way through, but it's basically showing how every time we fly by, the radiation, like the total radiation dose, ticks up. And they had a goal to keep it below a certain number over the whole life of the mission. And so this is how we achieved it. So truly, we're orbiting Jupiter in this fun flower petal sort of trajectory. But every time we come close to Jupiter, we're actually targeting to come close to Europa. There is another mission to the Jupiter system that is led by the European Space Agency called JUICE, and they are actually going to end up in orbit around Ganymede. So here's an animation of what one of these close flybys would look like, and it's a lot of information. You do not have to absorb it all, but it's kind of showing what the field of view of each instrument would be as Europa is coming closer and closer. And it has a little key on the lower left showing what instrument is on or off at a given time. I think these things are really helpful because I need to see pictures, and it just helps me to visualize, okay, what are we actually going to see? Oh yeah, sunlit side, night side. Okay, then we're going to rotate the spacecraft and we're going to scan. We're going to get these global mosaics built up. So this big orange, the big orange field of view is Themis, so getting thermal. Oh, that was the WAC, just came on. We're just taking nice framing images with the WAC, the wide angle. I think it's the WAC. Yes. So every one of these flybys, all the instruments are going to be on taking data over the period of each flyby. And then we're going to spend the next few weeks on the outbound part of the orbit, relaying the data back to Earth. So we have a few hours of intense activity and data gathering, and then several weeks of relaying the data back to Earth. So it's a really different mode of operating a mission than anything that I'm used to. I'm used to just orbiting the planet and just taking data all the time and sending it back to Earth all the time. All right, we're going on. Here's some fun spacecraft pictures if you like hardware. I like to see people in bunny suits. I've not ever really been in a clean room except one time. I think it's tremendous the amount of care and effort that goes into assembling these instruments and integrating them onto the spacecraft. It's just pretty astonishing. Here's some instrument photos. Let's see, so you can see what each one actually looks like. And I think this ice image is probably putting it into a thermal vac chamber for some testing, pre-integration. And then the tour, our big picture, we launched October 14 from Kennedy Space Center of last year. It was delayed a couple days because of Hurricane Milton. So the dates on this chart are off by a few days. So our next, so after we launched, everything checked out great. They've been going through instrument checkouts and spacecraft checkouts, and then getting just into the groove of operating the spacecraft in cruise mode. So everything is actually going really well. The next major event on the tour is Mars Gravity Assist. So in order to get enough velocity to get out to Jupiter in the reasonable amount of time, we need to slingshot past Mars and Earth to gain enough acceleration to get to Jupiter as fast as we can. So Mars Gravity Assist is not the end of this month. It's actually scheduled for March 1st. So keep your eye out for that. That should be exciting. Unfortunately, we do not get to take the covers off the ice cameras and take pictures of Mars, even though I asked. Because the cameras are not designed to be that close to the sun, which to me sounds, yeah, wow, we can't. So we cannot take the cameras off, the covers off the cameras until we are out past 3 AU. That means we have to wait until after the Earth Gravity Assist in 2026. And so after that, once we're out past 3 AU, then we can take the covers off the cameras. Jupiter Orbit Insertion, or JOI, will be April 2030. But that's just getting to Jupiter, and then there's a long pump down of the orbit, and we fly by Ganymede several times, and we don't actually take our first observations of Europa until March of 2031. Here is a lovely image of the spacecraft in its fairing on the Falcon Heavy rockets pre-launch. I was not at the launch because of the hurricane, but I heard it was fantastic. And that's the summary. I have a couple more slides, just a few, and then I'd be really happy to take your questions instead of me just talking. So first of all, there are some social media links. If you're on Facebook or Instagram, or it was Twitter, now it's X, I actually I'm not on social media, so you can just email me if you have questions afterwards. And then I have some backup slides. So why don't we just switch over to Q&A part, and I will stop sharing. I don't know if the hosts want to moderate or if I should just read the questions out of the chat and just answer. Great. Oh, okay, YouTube. All right. Are there tectonic features caused by the tidal forces on Jupiter? I think that we can say tectonic in terms of, yes, like faults, fractures, not like tectonic plates like on Earth, but faults and fractures for sure. We see those, and whether they're caused by the tidal forces between the orbit of Ganymede resonant with Europa and Jupiter, there are some indications through modeling that that would be what's happening. Let's see, it looks like a lot like microscopic topography from a scanning electron microscope. That is one of the cool things about imaging when you don't really know what the scale is there's this kind of cool scale and variance to natural features, like fractures, branches. Yeah, so you can see a lot of things that look similar to very tiny features and like really big features. And that kind of gives us some insight into the processes that form that kind of stuff, whether it's large or small. It could be the same physics, like creating similar morphology. I think that's a really good observation. Let's see, if we think that Europa can sustain some sort of life, what precautions are we taking to not contaminate it as we investigate the habitability? That's a really good question. There are whole offices devoted to planetary protection. And there's two ways this goes. One is protecting the surfaces of other planets from our contamination. Like we don't want to contaminate Europa with Earth microbes. We also don't want to bring any, if there were microbes out there, or we don't want to bring those back to Earth. But generally, planetary protection works in the way that we don't want to contaminate surfaces with our spacecraft, our Earth things. If we're looking for signs of life, we want to know that it's indigenous life, not terrestrial life that we brought with us. So Europa Clipper is not going to interact with the surface of Europa. Oddly, I don't know why this is, but at the end of mission, their plan is to crash it into the surface of Ganymede. I'm not sure why. But we definitely don't want to do that. So when you have a mission that's going to specifically look for signs of life, it has a whole other level of clean room, cleanliness, cleaning. There's like an extensive protocol that is designed to avoid contamination. And I think that because Europa Clipper is not designed to be a life detecting mission, nor is it designed to touch down on Europa. Of course, it's an orbiter, so it wasn't designed to that level. I hope that answered your question. Okay, and what is the water pressure at the bottom of the oceans and how would that be measured? That is also a really good question, and that is answerable. I don't actually have the answer to that question. You would need the gravity, of the planet, the gravitational acceleration of the planet, the depth of the water column, which we may not actually know with a great deal of certainty yet. And then probably other things like if you just assume, salt water, the general mass of water. So you can calculate that. It also might depend on what the thickness of the ice shell is, but I'm sorry, I don't actually have those values at hand. That sounds like a good question for graduate school, which I probably solved that problem at one point and then have now forgotten. I would think though that I'm thinking, I'm not going to speculate because I don't want to say the wrong thing, but I believe that because the planet is so much smaller and the mass of the ocean, the volume of water is so much larger that the oceans are quite deep. Is Europa tidally locked to Jupiter like our moon to Earth? Yes, it is. So the same face of Europa's moon, Europa always faces Jupiter, just like our near side of the moon always faces Earth. I actually think all the Galilean satellites are tidally locked. So we will be flying by to observe they call it the sub-Jovian, is the near side facing Jupiter, and the anti-Jovian face. So the first half of our tour will be flying by the anti-Jovian side, and the second half of the tour will be flying by the sub-Jovian side. And there's also differences between those two sides, and there's also differences in the surface from the leading hemisphere versus the trailing hemisphere. So in its orbit, the forward-facing, if you want to think about it, hemisphere is called the leading hemisphere, and the other is the trailing. And this has to do with its interactions with the plasma torus. And the next question is, did you say that the Clipper might fly through the mist of one of the plumes? I did say that. And that is something we will be looking for plumes with all the instruments, but ICE is in particular going to have a plume observing campaign, so where we can get high phase observations off the limb of the planet. And I think Cassini saw the plumes ejecting from Enceladus kind of incidentally this way, because the sun like shined on this great spray of ice water coming out of the planet, out of the moon. So we are looking to have some observing geometry favorable to finding plumes. And then if we do, we would be able to identify within some measure, like where on the surface they are coming from. And we have instrumentation that could take samples if we were able to fly through plumes. There's been a tremendous amount of analysis to assure people that this would not be dangerous to the instruments or the spacecraft. Let's see. Do you have a way to test the cameras prior to the covers coming off? Or do you have to suffer through several years of fingers crossed? We have turned on the cameras to test the electronics and the systems and the heaters and the sensors. We haven't been able to image with them because obviously the covers are still on. So everything's checking out. We have a gimbal test coming up. So there's going to be also a test of all the instruments turning on in whatever configuration they're in during cruise, to just make sure like all systems can work together. There's a fancy jargon name for that, but I've forgotten what it is right now. But the answer of your question is we don't have to be totally fingers crossed before we get to Jupiter, because at some point we will take off the covers and we'll do star calibrations. So this is one way that we calibrate cameras in space, is we take images of stars, and this astronomy people will get this. So basically the stars don't, move in the sky greatly. So we had imaged the star field and then match that up with the actual star field images from telescopic observations, and we can use that to calibrate the cameras. And like I said, our first flyby will be Ganymede. It will be on the day side. So those will be our first real images of a planetary surface. And we will probably take a picture of Jupiter too. Okay, the next question is, any idea why Europa was imaged with UV instead of IR to look for above surface activity? I think this has to do with, again, I'm not a UV spectroscopist. I have friends who are, and they would probably be hitting me right now for not knowing all these answers, but there is a UV, dedicated UV instrument on Hubble. And I believe it has to do with the wavelengths, what they can look for in terms of detecting certain materials of specific compositions. I don't think, and and you're astronomy people, so please correct me if I'm totally wrong about this, but I don't think Hubble has an IR instrument, but the James Webb Space Telescope is all IR. And so we have now a tremendous new telescope in space to make infrared observations of the solar system as well as astronomical objects. Yeah, I'm sorry I don't have a more coherent answer about UV because I know it's actually super useful, interesting measurement wavelength, and we will be taking UV observations from Europa Clipper, and some of those actually might be taken from farther out in the orbit, sort of like opportunistic UV. So I'm actually really looking forward to learning more about that. So and maybe I can answer your questions better in the future. How thick are the atmospheres on the moons? So the term atmosphere is a really super specific question, or has a really specific definition in planetary science. And so like I can say there's no atmosphere. What that means is that there's not enough molecules in the near surface environment to be collisional. Like they're just the density of the molecules that are there in what we might call an exosphere. There's molecules, it's just they're not dense enough to bump each other like we have a dense atmosphere on Earth. A really dense atmosphere on Venus. Titan has a dense atmosphere. But these airless bodies don't have an atmosphere technically. How am I doing on time? I also don't want to run your time out too badly, but because there are still more questions. You will cut me off if I go too long. All right. If we fly through the plumes, couldn't cross-contamination occur, or are we confident that the Clipper will be free of any life? That's a really interesting question. I think that they have minimized the possibility of contamination on the spacecraft. It will also be in this really harsh radiation environment for years before it even gets to Jupiter, and then it will be flying through the Jupiter radiation. I also think that at the height we'd be flying through the plumes, it could be that the material isn't actually going to make it back down to the surface, but I think that's a really good question and something we're thinking about. Any material that we pick up would be picked up by our sensors, would not be like released back into space. So I think that the chances are minimal, but that is not my area of expertise. So I can't put a confidence on that, but I want to say that it's pretty low chances. We definitely want to avoid cross-contamination. Someone put in a comment that is ASTAP in space. I don't know what that means. Can someone tell me what that acronym stands for? Oh, it's
Plate solver.
it's what?
The plate solving we use when we do imaging.
Oh,
So when you
okay.
mentioned take a
Dark
picture and
house.
compare it with what you
Yeah.
have.
Yeah, okay. I've heard of IRAF. Do you all use that ever? No? Okay, a step. Cool. I looked at star images once. It was baffling. We took some images of a comet with high rise, and it was like really different. Okay. Are the images going to be stacked like astro images or single shots? Again, like I'm not an astronomer, and astrophotography to me is like magic. So are you saying that like you would stack multiple exposures together to build up signal? I don't know if I'm understanding. Okay. I don't think so because we have designed our imaging system and strategy to take images in one pass. Also, on each subsequent flyby, we'll be looking at different parts of the surface under different lighting conditions. So over time, what we can do though is stack those images in when we have a very good topographic model of the surface. and we can do some photometrically correct all the images and build up a more like a photometrically corrected global mosaic. Might not be exactly what you mean, but in a way we might end up doing that in some areas, because understanding the surface reflectance properties of Europa is definitely one of our goals, and that takes multiple repeat imaging. And let's see, one more question. If you fly through plumes, will the spacecraft possibly get iced up like an airplane can be? That would be simultaneously awesome and terrible. If there was that much ice ejecting from the surface of Europa, that would be actually astonishing and, you know, unprecedented observation. I think if we observed that, we would probably be able to measure, say, like the particle density, particle size, and then decide, is that something we actually want to do before we would actually try to fly through something like that if it were persistent. I would think we'd absolutely want to avoid that. Right. Missed opportunity to name an instrument Hal, Dave, or Bowman. This is actually very funny. You're right. Why didn't that happen? Our project scientist, Bob Papalardo, is super into 2001. And he actually had a monolith constructed that we bring to all of our team meetings. And we have signed the monolith. It moves around, or we've had multiple monoliths constructed. We even have like a Zoom background with like a monolith in it, but I didn't put that up because I didn't want to look silly, but it's a thing. And there's more references to 2001: A Space Odyssey in our team lore and culture. Any idea of the length of exposure for the non-sweeping shots? Let's see. So framing images. We have two modes of imaging with the cameras. We can image in framing, like you just expose the whole detector at once. The other mode is push broom, where we build up the limit image line by line as we're flying over. The framing images are more useful for far away. I don't know the exact exposure time because it probably varies on the expected reflectance off the planet. If it's in illuminated day side, night side, Jupiter shine, we're going to take some Jupiter shine observations. So the push broom images, though, they have to be timed so that the integration time of each line kind of tracks with our ground speed. Otherwise, you would smear or fail to resolve all the surface features. And so that time changes rapidly over the flyby because we're in this highly elliptical orbit, and it's like we're coming in from far, and then we're going to come in really close, really fast, and then zip away again. So that time is always changing, which complicates the whole imaging strategy and complicates the answer to how long are they exposed for. So we're going to have to segment the images to change the line time over the flyby. Super fun. It ends up being like microseconds at the highest, closest approach. We can't do push broom imaging from far away because of that reason, the exposure time, if you want to think about it, the integration time would be so long we would saturate because it'd be like seconds, and that's just too long. So that's when we switch back into framing mode. All right, but great question, technical. How much direct remote control do you do versus give onboard systems direction to make its own decisions of sorts? That's a great question. What we have is we have planned our trajectory, and we have a nominal plan for operating the instruments on each flyby. And that is so we can plan our power consumption, data volume, downlink volume, uplink volume, all of that. We cannot change our trajectory at this point. We're committed to flying this plan. There's no automated onboard, like autonomous systems, as far as I know, what they do is they send the commands to the spacecraft. There is a delay, a one-way light time delay before they know, I'm sure, the telemetry comes back, to confirm commands were executed. I'm actually not really involved in the mission operations side, so I've never heard them talk about autonomous navigation. I think it's all commanded. I'm not sure, but I'm pretty sure that's not part of our plan. What we can do is, I think if we have opportunistic discoveries, we may be able to alter a few flybys in advance because of the time it takes to downlink and uplink the data, analyze it, plan a new command sequence. We can probably retarget different locations on the surface if we have the opportunity, say we observe plumes or whatever active processes. But as far as the trajectory itself, it is set. Great question. How do the cameras produce a stereoscopic image for 3D analysis? So we have the wide angle camera is going to be our topographic instrument. So we have, it's so wide, like wide angle, that we, in imaging in with these, I don't know if you primarily use CCDs or CMOS detectors in your telescopic instruments. A lot of spacecraft orbiting instruments at Earth and at other planets and our cameras have used CCDs. CMOS is what we're using. So this is a really great for, and I guess it's what's in our cell phones now. It's a great detector for this radiation environment. They're a little more radiation hardy, but also they're kind of infinitely programmable. So with the same detector, we can take like a clear framing mode section of it. We can also have these color filters over specific lines. And so when we're in the close flyby range with the wide angle camera and in push broom mode, we're actually taking a line that's basically, because of the angular field of view, forward looking, nadir looking, and backwards looking. And so with these three lines, we will build up three images from basically three different look angles and then combine those into a topographic model like that. No, I'm kidding. It's a super complicated process. But having stereo acquired on the same orbit is hugely advantageous to processing those images because the look angles will always be the same and the illumination of the surface will always be the same during one of those imaging campaigns. So that helps tremendously in reconstructing the topography from the stereo data. Does the spacecraft have an engine so you can fine tune the orbits? Does it use momentum wheels for attitude control? I think yes to both. There are definitely reaction wheels that they use to adjust, like offload momentum, change orbit maneuvers, but I think they also have jets or like little rockets on the spacecraft. I'm not a rocket scientist, obviously. So they can also do trajectory maneuvers with things like with that kind of engine. Yes, actually, I remember there are engines on the spacecraft. I don't know the kind of fuel they use, but yes, so they have those engines to adjust trajectory and do trajectory maneuvers, but they also have reaction wheels to adjust momentum, and all of those things contribute to spacecraft jitter, which is another thing I work on. Great questions. You all are very knowledgeable about this. You probably know more than I do about actually like spacecraft and spaceflight. I spend a lot of time looking at pictures of rocks.
Well, the topic's inspiring. I mean, this is probably the most questions that have been asked after a presentation in
Great.
recent memory. So yeah, this is really fascinating, and it was really great presentation. Thank you so much for taking your time.
Great. There is one more question. I can answer this one, actually.
Yep.
This one I know. The question is, do the 7 filters cover the whole visible light spectrum, or are they narrow band looking for specific absorption lines? They cover from blue-green to near infrared. And we have some filters are wideband and some are narrowband. And I don't have that information at like the tip of my fingers, which I probably should, but we do have like the several, I think 2 are near infrared, and then we have several other, like 5 more in the like narrowband color filters, so we can build up multicolor images. And then there's a large clear filter, so panchromatic. All right, last question. What are you most looking forward to learning or confirming from this mission? Thank you for asking that. I know that this search for habitable environments is super exciting. I'm keeping that in mind, but personally, I really, really love to be able to identify and observe changes on other planets, like surface changes, active processes. We take this for granted on Earth because our surface of our Earth is always changing because of weather. We have lots of imaging of it. But if you know, like, here's this picture of Europa that Voyager took or Galileo took, like, that's what it looked like at that moment in time. So we kind of had this idea, like, that's what it always looked like. Mars, same thing, the moon. But as we're able to take spacecraft to these planets in our solar system and observe them over a long amount of time relative to just once, like 10 years or more, at high resolution, we're able to build up like a time series of images, and we can actually observe active changes happening on Mars and the moon. And that's really exciting because then it puts those planets aren't like these static bodies. They're actually actively changing all the time. Europa clearly has a lot going on in its surface. So I am super looking forward to, over the course of the mission, seeing something change on the surface. And then we can start to put some kind of constraint on how rapidly are things changing? How are they changing? Is it like faults moving past each other? Is there some kind of like eruption on the surface, new impact craters? I don't know, but that's the kind of thing I'm really excited about. Maybe not be like everyone's thing, but personally, that would be pretty cool. Well, I want to thank you all for listening to me talk for so long and asking super great questions. It's been a real honor.
Likewise.
Thanks.
And we're all rooting for the Europa Clipper.
Great. It's going to
Yeah.
be very exciting. Keep an eye on it as it goes around Mars. I think that what they will be observing is there's going to be a dual like radar observation experiment with the Mars orbiting radar and the Europa Clipper Reason radar. So that could be pretty cool.
Very cool. Yeah. And coming
right.
right around the corner too.
Well, you all stay safe, and I'm glad you did not brave the weather tonight. It sounds awful. Thank you.
Thank you, Sarah. You are welcome to stick around if you want to. We've got the rest of the meeting. So again, thank you so much.
I think I will duck out. It's dinner time here, and I need to go and eat something. But thank you again. It's been great. And if I just want to do one thing, and that is because we report, I want to get an idea of how many people are here. It says 44. I think that's more or less. That's a great group. I really appreciate you zooming in to talk to listen to me.
We had 49 at most. And
wow.
Chris, did we have any on the Zoom? Oh,
Wow.
so 69 or
Great.
whatever that math
Okay.
is. 71.
All right. All right. Thank you all.
Thank you for coming.
Yeesh,
Good,
all
thank
right.
you.
Good night.
Thank you. Good night.
Yes, I'm working on that. Oh, what's this? What's in the sky? Bill, you ready? I can do the slides for you.
That's me. No, you actually don't have the slides. I've
Oh.
got them in mine. And if I could, if you, whoever's got the screen, if you could share.
Okay, I think you can grab it now.
Okay, gotcha. Share. No, I want to share.
Well, we see you now.
Doing. I'm used to Teams. I'm sorry.
Hmm.
Share screen. There it is. All right. Here we go. All right. Can everybody see that?
Well, we see the presenter's screen before and after images, slides.
Gotcha. That's not it. Hack. Is that it, or are you just seeing it all now?
We're just seeing the workspace of PowerPoint.
All right, I'm dying inside. Give me just a second. Okay, what's going on here? Resume slideshow. I'm not sure I understand this.
If you go down to your bottom right on the screen there, well, it disappeared, but yeah, down the very bottom right, there's a little screen. Looks like your mouse is ever to the right, that one right there. Not
It's
working.
unresponsive. Let me stop sharing and then jump back on.
You gonna share, Chris?
Chaos. Give me just a second here. All right.
And I feel good when I get my microphone working.
Okay. All right. I will get this. I can do this. One second here. Ugh. All right. Let's try.
We're still just seeing you.
Yeah, stand by.
There you go. Oh. It worked.
Is this the
Yay.
full
There it
screen?
is. Yes.
Yes. Okay. So here's everything going on for the next month. Featured in this first shot here is Lonnie Griggs great Hubble palette image of the Rosette Nebula. Really good stuff. So we got a double transit season coming up. There's times of the year where there'll be the moons will align, and we'll have a run of several weeks where we've got a couple of moons in the showing shadows on the sun at the same showing shadows on Jupiter at the same time. And so we got one coming up here on the 25th with they're all Ganymede and Europa. So hey, Europa, it's a theme. They're all very favorable times too, which is great. There's some that are happening during the daytime, but these are the good ones that are happening at night. Speaking of shadow transits, because we're and it's not, last month I said it was the springtime of Saturn. Apparently, technically, it's the autumn in Saturn, on Saturn. So during the two equinoxes, we get Titan's moon in the way of the sun, so that we can actually see the shadow. And of course, these times around are not favorable. It's daytime stuff, but as I've said before, it is possible to image Saturn in the daytime or see Saturn in the telescope in the daytime. Just be very careful, because Saturn is getting closer to the sun. Be very careful about looking Saturnward when the sun is around. T Coronae Borealis, it still hadn't blown up, but it's any day now, so it's always worth mentioning, I suppose. We still got the Parade of Planets. It's going on through February. We've got six planets in the sky that I think that just still are all visible at the same time. We might be losing Saturn. The new moon, the next new moon is on Thursday, February 27th. This is a really beautiful shot of Patrick McMahon took of an extremely young moon. Mercury in the evening, so it's going to be at its greater eastern elongation, highest in the sky on March 7th, and it'll be in a gibbous phase, and it'll be about 16 degrees above the horizon at sunset. So and then we've got a total lunar eclipse. It's just about the entire continent of North America is able to see this, I believe. And it's on Thursday, March 13th. 10:57 p.m. is the earliest. It's a first contact. Maximum is around 2 a.m. and it ends around 5 a.m. So no evening, no sunset or sunrise eclipse this time. We actually get a really well-timed eclipse that runs through the middle of the night. Christian Sensic has got this image of a lunar eclipse that happened in 2022. And there's a little bit more here. This is another visualization of what's going on here, and you can see greatest eclipse at 2 a.m. The information that I get, I love the information at timeanddate.com. So that's a really great reference for a lot of things, but especially with eclipses. And we got the Messier Marathon. So Bob Circus is going to speak to that a little bit later on tonight. But for a few weeks, we get to have some nights where we can see all the objects if we try. So that's a thing that's coming up. So the constellation I want to feature tonight is Lynx, which is a lynx. And Johannes Hevelius is the one who made up this one in his catalog, is a celestial atlas. There's 5 stars with planets, and there's 5 formally named stars. You don't hear about Lynx a whole lot when you're thinking about deep sky objects and stuff in the sky, but this is actually kind of a surprising one. So if you've ever heard of the Intergalactic Wanderer, this is a globular cluster that was at one point thought, because it was so far away, it was thought to not be a part of the Milky Way galaxy. Yet it is, and it was discovered to be a part of the Milky Way galaxy at an orbit of about 300,000 light years from the Milky Way's center, which is about twice as far as the Magellanic Clouds, and it takes about 3 billion years to complete one orbit. So this is Adam Bloch's handiwork. So there's the UFO galaxy. This guy is it's close to Edge On. You can see kind of like the Deerlick galaxy. It's kind of got an angle to it. It's suspected to be a barred galaxy, and I've spoken about this feature before. Can you see my mouse?
Yes, we
Yeah,
can.
we can see it.
Okay, cool. So in the middle of this galaxy, if you can see it very faintly, you see the top of an X here. And this is actually created by what's called gravitational torque. Basically, the bar in the middle of the galaxy actually disrupts the orbit of stars around the center of the galaxy, and it basically that's one thing that actually adds to that siphoning effect. It's actually sucking gas towards the center of the galaxy, but the X is a structure that's actually believed to be an actual buckling instability of the bar. And I've had a few buckling instabilities at bars in my time, so I get that. This is a picture of mine. This is the Needle Galaxy, and it's believed to be a barred galaxy as well. Being edge on like this, you can very clearly see the X in here. So we're talking about that same sort of instability from an edge on. So that's a hint that we're looking at a galaxy with a bar in it. The supernova factory. So this is NGC 2770. It's so called the supernova factory because of three supernovas that have been seen in it in the last 20 something years. The latest one, which was in 2008, was the first one to actually be detected by its X-rays, where normally supernovas are found, supernovas are discovered when visible light is seen. So this was a precursor to that visible light. So they caught it early. This is an image from the Hubble. Then there's NGC 2500. So this one is clearly a barred spiral, and barred spirals are a part of the life cycle of most spiral galaxies. It's about 2/3 of the spiral galaxies have a bar, and like I said before, the bar is actually uh, influencing the stars and the gas in the outer parts of the galaxy with a process that's affected that's triggered by gravitational torque. More about constellation links. The Sky Live actually has details about 136 deep sky objects and links, and of course these other links here for more information as well, including constellation-guide.com, which is a favorite of mine. And keep looking up. So this is Jim McCatherine. He captured an object. I'm guessing this is a planetary. That's called Jones Emberson 1, and that's all I got.
Well, good. Very, very good presentation. And when do you think you might be sending it to the e-groups on the Fort Worth, Maine?
I'll do it tomorrow.
Okay, great. All right. So I will share the screen. Oh, wait a minute. Let's start the presentation. Then share the screen. Good. Let's see. These are the folks that'll be giving comments on the monthly reports. So now's the time to be thinking about what you're going to be saying. And I have a couple announcements to make. So let's just jump into that. First, the announcements. Oh, that's right.
Can't see your screen. I mean, can't see the
oh,
can't
well,
see
good.
the slides.
All right. Stand by.
No worries.
How about now?
Now we see it.
You've got it. You've got it in showing in PowerPoint,
Right.
the workspace.
Yep. Halfway there.
You can do it.
We're rooting for you, man.
Thank you.
There you go.
All right. So I'm right to the announcement with the pre-screen. So let's just do it. All right, so we have a big announcement to make concerning one of our members that have been very influential to the club, and that is John Germani. As you know, has been a longtime treasurer. He served his entire 5-year term that expired in June of last year. And then he stayed on in a couple of different positions through the end of the year and up until today, where he's finally pulled back and he is relinquishing all his responsibilities that he had with the club. And as you can see on screen. He's he's made the club much better with his record keeping systems that we'll continue to use and improve upon. He was always a stickler about documentation, and as he managed the membership handbook, and he did implemented some processes so we could move away from paper records. And the big example that I can think of is hold harmless code of conduct. So after another issue that would come up that the club needed to manage, John came up with solutions. Plus, he loved astronomy and participating in Outlook activities. But we're grateful that he's been with us and all that he's accomplished for us. So just a round of applause for John. All right. So this slide has to do with an upcoming examination that we're working on as from the board. And Robin's going to talk about this. So Robin, take it away.
Hello, everyone. Our bylaws indicate that physical inventory of all the club's assets need to be performed. And to that end, Cy and Bruce and I have worked to come up with a plan to accomplish that. And this means that everything at Rising Star and everything in any club's members' possession will need to be cataloged. We're going to put it in a spreadsheet, give it a unique number, and apply a sticker to all of the equipment. So what we ask from our members are two things. We need every member that has any equipment that belongs to the club to photograph the equipment, describe the equipment, and email a list along with your photograph and description to the email on the screen, inventory@fortworthastro.com by February 25th, please. And the second thing we need is volunteers to assist with the physical inventory out at Rising Star. So our planned date is March 1st, Saturday, March 1st, with a backup date due to rain of March 8th. So if you could email your availability if you'd like to volunteer to that same email, inventory@fortworthastro.com. We would appreciate your assistance if you are available. That's it.
Very good. Any questions for Robin before we move on? Okay. Oh, okay. So Bill, do you know if the 3RR slide was left out? And what about the budget items? Well, we'll just move on. So Patrick, you're up. What do you have for us?
All right, can you hear me?
Loud and clear.
Okay. All right, so I don't know if you guys saw the group earlier this evening. The first one, we're actually going to reschedule that for Tuesday. So I'm not going to be there for that one. I'm going to be down in Crowley. I'll get to that in a minute, but Maru will definitely be up there. So just need a couple of scopes to help them there. Friday is a daytime one. I know it's going to be hard for a lot, but if anybody's able to help get with Tyler, one of our new members, he's organizing that. Next one. All right, so Tuesday, like I said, the Thursday star party has been rescheduled for Tuesday, but I'll be down in the Crowley. We'll be doing a star party for the planets at the Crowley Public Library. So anybody in that neighborhood, feel free to help out. Then there's some astronomy badge work on next Thursday over in Keller. I'll be there for that one. So if anyone wants to help out. Next slide. And then on March 1st, this is a reschedule from January. This is a place we've actually been been to before community there, so we usually have good turnout. So we got that one on March 1st. And then on the 14th, we have elementary school there down in Hearst. And I think that's it. There's one more. That's it.
Okay.
Bruce, the 3RR stuff is in the business meeting thing. I
Okay.
don't know what my logic was for that, but it's in here.
Okay, very good. Thank you. So John, you want to talk to us about Tandy Hills? Well, appears that John's not on or he's on mute, but this is the slide to introduce the Tandy Hills, and I think this is important because we have an upcoming star party on March 8th, which is the last evening before we move on to daylight savings time. So we'll be able to start early and have more nighttime activities to look at the moon and the planets. So if you need more information, go out to the Tandy Hill website, and you can check out what they say about that, about their Prairie Sky Star Party that we do with them. Oh, here's more information on that star party. Young astronomers, Cy, you're up.
Is there another slide? Okay, yeah, okay. So we're not going to do our next class until March. And something we're looking at, and we just thought of this today and we got to reach out. Rather than trying to do it on Tuesdays, we're seeing if we can do it on Fridays so we can get more kids available. But we got a couple weeks to work that. And I think the class I'm going to do on that is probably going to be on comets, because there's a comet that's going to be visible, hopefully by the naked eye somewhere like within the end of March, beginning of April. So that will be the class, but I'll get more slides together and figure out the schedule for the rest of the year. But our next class is in March, either the last Tuesday, fourth Tuesday, or the fourth Friday. We'll let you know.
Okay, sounds good. So before I turn this over to Bob on the 1687 Foundation, I did want to give an update on an action the board took. But I did want to state that we've got quite a few members and visitors that probably don't know the background on 1687. So I just wanted to say that we've been working with 1687 for up to about a year now. And they're a unique retreat ministry where they invite nonprofits to come out and give them an opportunity away from all the hustle and bustle of their normal lives out there at their ranch south of Cross Plains. And this gives them an opportunity to focus on, the nonprofits can focus on the things that are important to them, what the nonprofits are doing. And they also, the ranch also, the foundation also offers programs that the nonprofits can participate in, whether it be horse riding for the kids or star parties, which were added to the list of activities just last year. And there's only one group that provides star parties out there, and it's us. It's our club. So what do we have to do? And what we signed up to do is to hold star parties if they're requested, and have at least 3 telescopes that their guests can look through. We also use this opportunity to do electronically assisted astronomy because that's such a cool thing, as well as looking through the eyepiece. So we do need people out there to participate in these star parties. And then knowing that the good news is, and Bob will tell us a little bit more about this momentarily, but the 1687 has asked us to come out, and we have star parties already on the schedule, or will shortly have them on the schedule. And what we need is more club members to start coming out to these star parties. We know it's a hike from our normal meeting venue up at the University of North Texas Health Science Center. It's approximately 135 miles out to the ranch where we'll give the star parties. But the nice thing is, the foundation pays us for our time out on the ranch, getting these star parties. And what the board wants to do is defray some of the fuel costs that members incur by driving out to this event. And so what the board has done is we've agreed to offset the fuel cost by $50 per star party for those individuals that would like this reimbursement. This program will start in March. So what we're doing is we're utilizing some of the money that we're getting from the foundation for the star parties and just passing it along down to the members who would like some reimbursement for their to defray their costs of driving out there. We know it doesn't cover probably all the fuel costs that they have or the wear and tear on their car, but we wanted to share the wealth, and in order to inspire or incentivize more people to come out and participate in this worthwhile outreach activity. And these star parties are just like all the other star parties that we have, where you get the endorphins flowing as you interact with the women and the children and the men that come out of these nonprofits that come out to look through our scopes. So I think it's just a unique opportunity that we'd like to keep going and fully staff in the months and years to come. So that was my announcement on the funding of the fuel reimbursements. Bob, you want to take it and tell us about what you have to say on the 1687?
Yeah, sure. Thank you. So typically, well, we have 5 upcoming. March 8th. These are all Saturdays except for May the 9th, which is a Friday. So Saturday's Young Epilepsy Adult Retreat. And we will not have to be concerned. This one, I actually had to think about for a minute, but then I was told that we're only concerned about operating telescopes. They will have doctors and folks there in case one of the participants has an episode. So that should be a unique experience. I have found when I've gone out to Dinosaur Valley to help, and I wind up with I don't know what the right word I'm looking for. I've had experiences with sight impaired and visually impaired folks at the telescope, and I find that extraordinary. You have to be more patient, but the value, I got a tremendous amount of value from that. So there's that one on the 8th. On the 15th, we have the Center for Autistic Families Retreat. This is we did 2 of these for them last year. That's always really cool. March the 22nd is for sight impaired veterans. Cy is going to lead that event for us. Saturday, April the 5th, Grace After Fire Veterans Retreat. That's a ladies veterans group. This is the second time for them, and that's a great experience. And then on Friday the 9th of May, the group is called the Open Door Staff. I don't know a whole lot about them. It's the first time for them, and it is usually we try to do these on Saturday, but this group is leaving on Saturday at noon, and so Friday the 9th is the only opportunity for us. Generally, we get there around 6. Well, we're invited for dinner, and their dinners are pretty dadgum good, and they are concerned if you're vegan or vegetarian, they'll prepare a special meal for you. So I'll be sending out an email with all of this information tomorrow. And if you could reply back to me or the 8th, Chris Ashford prepares our monthly intro to astronomy. He does such an outstanding job with that. And Chris is also going to lead, I believe it's the April the 5th event. So by that, he's just going to coordinate it for us. So that's what we have. That's how pretty much it works. It's a great experience. The facility is awesome. And you're 10 minutes away, 15 minutes away from Rising Star. So typically what I do is I go to Rising Star first, I get set up, and then I go over to do the outreach, and then I hustle back to Rising Star. And as Bruce mentioned, we do remote astronomy from Rising Star at these events. So it's pretty cool. It's a great experience, and we welcome anybody's participation.
Oops. Sorry, didn't mean to leave that slide. So if anybody's interested in helping out on any particular dates, what do they do?
Send me an email. But I'll be sending out an email either tonight or tomorrow morning via Night Sky Network.
Okay, thank you. Oh, there you go.
Yep.
Sorry about that.
And that's okay.
So moving on to the Rising Star Report, Michelle. Oops.
Okay.
There it
Yep.
again.
Yeah, don't skip me too. It'll be short, but not that short.
Okay.
Did want to address number one, the fact that I think some of you a few weeks ago had problems. Someone had on the green building where we have the composting toilet, someone had used the key to open up the shed and taken the key and the box that it's supposed to be in and put it inside the shed instead of putting it back on the outside. So that created a little bit of a problem for people who were trying to get in because they had no key. So for the next couple or 3 weeks, just always remember, if you open up the green shed, use the key, open it up, put the key back in the box that's on the building and keep it that way. We will be over the next few weeks installing a new doorknob, and it will have a keypad. It's similar to what we're going to have or what we have on the container where we've got the sleeping quarters. This is a little bit different in that you, of course, will be able to latch it from the inside, and the code on this one for the green shed will be the same code as what's on your gate, your entry gate. So you'll have that code in your head. You should know it. It should be easy enough to remember. So that will help to alleviate that specific problem. And I believe it does have a setting so that you can unlock it and it can remain unlocked while you're there through the evening. So you don't have to punch in a code every single time somebody wants to get into that building. And then of course, as with the current setup, the last person to leave should make sure that the shed is locked. So once that happens, we will let you know that has happened. But at least that will, until we get to that point, just always remember to leave the key on the outside of the building. Another item to remember is that Eastland County is still in a burn ban. There is also a place, I will email the website out to the group at the end of the meeting. It's actually Texas A&M. They have a burn ban map that comes in very handy if you want to check Eastland County for burn ban, if you're going out there, or if you, like me, I discovered the burn ban map several years ago because I camp at various state parks. So it's always nice to know if there's a burn ban in effect where I'm going. So I will be going ahead and getting that email out to you over the probably tonight after the meeting. So that's what's going on at Rising Star right now.
Okay, thank you. The next up is the Palapito Mountain State Park. Tom, what's going on there?
We're still on schedule to open up latter part of the summer, I would believe. And as far as I know, the astronomy site tentatively is going to be in the back side of the park on top of a hill next to a pavilion, which lights can be turned on and off. And that's where we'll have star parties and stuff.
Okay.
So everything's looking pretty good.
So I did want to make note of what the state park has recently done, and that is those club members that are representing FWAS with the Palo Pinto Mountain State Park partners, and they've helped the well, what they've done is they volunteered their time on the weekends to clear trails at the state park and to and other tasks. And so each of these following people, Nazreen, Mark, Tom, Michelle, all received a plaque marking their efforts back in 2003. Blood, Sweat, and Poison Oak posters, as I understand. So they thoroughly enjoyed the effort, and their efforts were recognized by the state park. So I just want to make you all aware of what some of our members are doing in support of the club. And then this one's mine, the Cross Plains Public Library. This was our third event in the library. We meet in their little meeting hall, and we had there were 27 folks from the Cross Plains area come. It was a wide variety of ages, from the little one that's in the arms of the woman in the gray sweater in the foreground, up to people as old as we are in the club. And the presentation was given by Robert Cargill, and he did a show on binocular astronomy. And then we went across the street to a parking lot and we looked for bright stars and planets and a couple of deep sky objects that might be available. Unfortunately, back on February 8th, a cold front had blown through at about 5 o'clock, and most of the people stayed momentarily at the outdoor activity, but a few diehards stayed until the very end, when we finally said that we had to pack up and head for home. So it's really kind of interesting. There's quite a few folks in the Cross Plains area that are interested in astronomy. And then we had three people from the Cross Plains area become members shortly after our last presentation. So very good. And let's see, who's this last one? Oh, website and media. Mr. George, do you want to give us an update? Okay, apparently George isn't on, but I do know George is doing maintenance on the website, and we're just trying to make sure that things are working as designed. So let's go to the financial report. Interesting. Can I stop sharing, Constantine, and let you present?
It should be on the next slide, is it not, Bruce?
I don't know that. No.
It's not. I didn't get a slide. I don't.
Okay. Let me see.
I got a bunch of budget slides, but I didn't get the
That's
financial.
okay. I'll go ahead and see if I can pull that up real quick, and then I'll share my screen if that's all right.
Okay.
Thank you. Sorry.
Almost there. Patience just a little bit longer, please. So can everyone see that?
Yes, sir.
Terrific, thank you. Okay, there's not been a whole lot of activity. Our funds are holding steady. As you can see back on January 10th, we reported $38,658. And today we're sitting at around, not today, but the 10th of February, we're sitting at around $38,906. The income has been primarily from members. We've had 6 new members in the month of January and 2 through the 10th of February. Expenses, very minimal. These are routine monthly expenses for our various vendors that we're using. The bottom half of that report talks about the Rising Star Development Fund and Loan, and these are funds that we're tracking within the general operating fund, and there's not been any activity. There wasn't any in January, and in December or January, so we're still sitting at 4489. We do have some payments coming up in April, May of about $942, and we have a total outstanding loan of $14,000. So far so good, and now that we're going to be having a few more of these star parties at 1687, we'll have some additional income to pay down on that loan. And if no one has any questions, that is really all I have to report.
All right, thank you very much. Let me know when you stop sharing.
I'm trying. Okay.
Thank you.
All right, thank you.
All right, so we're back to the business meeting. All right, so let's jump into the budget, and the board has been looking at the annual budget. Well, let's go back to the bylaws. The bylaws said that the president has to assemble an annual budget and present it to the executive board back in November. That was done, and we reviewed it and tweaked it a little bit. And then when we met in January, we took another look at it because we were looking at some proposed spending items, but we did finalize it, and in January we approved it, and I wanted to present it to you today. And this is a summary of what we came up with on a month-to-month basis. The first section along the top talks about income and where the income comes from. And then you can see our expenses by the 4 groups that we have in charge of spending money, apparently, at the club. And you can see that in terms of the annual totals on the right-hand side, we're running a slight deficit of $945. And that's because we didn't know where we were headed in terms of some of our fundraising activities. So we didn't put in a guess on how many 1687 star parties we have, but we've learned today that we have 5. So we do have more than enough money to overcome our budget items for this year. And that was one issue that came up at our last club meeting, where people wondered why we were running a deficit. Any questions on this slide?
Bruce, are there any 1687 Foundation star party numbers in the figures today, or was it assumed to be 0 back in November?
We assumed them to be 0. At the time we started this process, we didn't have a new memorandum of understanding done, but we thought we would have that completed. We just didn't take a guess at how many we would do.
Okay. And the income from those is the same as last year? I mean, per star party?
That is correct.
Okay, thanks.
Good questions. Any others? So if we want to take a preliminary looks of what normally we expend money on as the club, you can see where our income comes from new members, renewing members at the top, and then the expenses that we run into that the club pays for, that are essentially what our dues pay for.
Hey, I have a quick question, Bruce, just because I'm curious. We didn't have any electrical bills greater than $33 last year.
That I believe is correct.
Cool. Thank you.
Okay. I think though the January bill went to 45 though.
Did it? Huh.
But like Sarah said, I shouldn't speculate since I don't have the data in front of me. Right, any other questions? Okay, so the membership committee, most of their expenses are just to replace consumables and making badges and a few things like that. Although we did look at and did approve them purchasing a printer. So that would be the club printer that would move from membership chair to membership chair or whomever does the badge printing. So we'd have consistency in the badges and we wouldn't be expecting the membership chair to cover the wear and tear on their printer for club activities over the year or two that they're in that position.
I have another question.
Go ahead.
Is there a need to produce for existing members a card every year?
I don't.
That's a time and materials expense, in my opinion.
I'm not aware the club does that. Anybody? I've had the same badge for a number of years.
Have you? Okay. I wonder if it's officers that get badges every year. Okay.
Okay.
Thank you.
Outreach committee. So here we have what's new this year is printing expenses. We thought we would do better on sending our print jobs to companies that have better printing facilities than maybe our members do. So I think the plan is for the outreach committee is they would tweak the brochures that better present descriptions of the club, and they would have those essentially professionally printed. So we would have those on hand for distribution. And those account for quite a bit of the costs, as well as handouts at some of the organizations we did for the kids. So they would remember that FWAS was the first person to give them something associated with astronomy that's on their bulletin board in their bedroom. So that's what that is. We talked about the board approved purchasing more banners to advertise the club's names at club events, and then to purchase the golf shirt style shirts for coordinators. So we would represent the club in a stylish, good looking way out in the public. Any questions on that? And then the last one is a list of the normal expenses that we would incur out at the observing area. On the left-hand side, just some things that we need to keep the area in the shape that we'd like to have it in, keeping the Ansett bay, keeping the compost operational, and then lawn care activities and parts and fuel. Any questions on the observing area committee? Okay. Oh, let me go back. So I don't know that it's required, but I would like to get a vote tonight on approval of the budget. And so I'd like to hear a motion seconded, and then we'll vote on the budget.
I move
I
we,
make a motion that we approve the budget as is.
I second.
Okay. So all those in favor, can you raise your hand or say aye?
Aye.
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 I make a motion, we vote by
Aye.
acclamation.
Okay. Well, let's do it this way. Those opposed, would you voice your concern or vote no in audio so we could have that? All right. Well, very good. Thank you very much. Oh yeah, the standalone generator prohibition. Did want to go back to that since I didn't have a slide. So the board also at the January meeting put in a ban for standalone generators. And so the picture is trying to illustrate what a standalone generator is. It's a generator in a field supporting astronomy activities, whether it be providing power to a rig out on the rising star, or used for maintenance activities. What this ban does not cover is those people that have generators associated with RVs because they accepted liability for the generators in their agreement to take their RV out there. So we thought the ban was appropriate at this time because we do have power out at Rising Star. And so the need for generators has waned. And so we think this was a good time to put in the ban on these standalone generators. And then you can get also the 110 volt there's power available at the pads and in the 40-foot container. This is a repeat of what I tried to discuss at the last meeting, but I did want to go over it again and ask if anyone had any questions on this. And like several other presenters, I also plan to send out a note via the Night Sky Network that we've implemented the ban. Oh, and here we are on 3RR weekend, so that's very good. Thank you very much. I did announce that we did secure the last weekend in October for the club to go out to 3RR, Three Rivers Ranch now, as it's called now. And those people that have been out there before, the picture on the right tells you everything you know. In the background, there are the 6 cabins that are available, as well as the observing area. Coming closer to us, there's a couple of bunk rooms that are out there that we will reserve for people to sleep in as well. And then there are some public restrooms and shower areas that they also provide as part of our participating at the 3RR weekend. And then the rest of it has to do with observing activities that are available at 3RR. The club's been going out there for years. My first time was last year, and I kicked myself for not going earlier. People talk about it all the time and have enjoyed their participating at 3RR. And one of the reasons why we couldn't get the new moon weekend at 3RR in October is because 3RR reserved all the new moon nights for public star parties. And so if you're in the area, if you're driving up in that way, you might schedule that into your trip so you could stop in and go through one of their star parties and listen to their presentations about astronomy. And so I put both URLs for the 3RR facility as well as the star parties that 3RR are going to be presenting. And you should check them out and see what, and don't spend as much time or don't procrastinate as long as I did. I encourage you to take a visit and enjoy the dark skies that they have to offer.
I'm in.
Okay.
It's the only place reasonably close that's darker than Rising Star.
There you go.
And it's not bad on the 24th. It's an 8:30 p.m. moon set.
Yeah.
Yeah.
It's pretty good.
Trip last year was the first time that I'd ever literally seen the Milky Way from horizon to horizon.
All good justifications for making the trip out to 3RR. All right, so we're up to the 2025 Messier Marathon. Bob, that's yours.
Good evening, everybody. Just a brief update here. We had hoped to have a public Messier Marathon. The logistics for doing that on the 29th, not really gonna work very well. Aside from getting everything that we want ready, the key thing is the Noble Observatory. I wasn't sure was going to be 100% ready because the weather has just been atrocious. So it is now going to be on the 29th of March. It's for members only and members invited guests. We'll be sending out emails tomorrow with some general information, and but we will have it on the 29th. And we will live stream. That's something we certainly are going to do. From hopefully, if the Noble is ready, from McCathern Observatory and a couple others. And so that'll be available to members and anybody on the internet. The last time we did remote EAA to our YouTube, we had I want to say over 100 people across the globe from Europe and across the United States watching. So we're going to be publishing that pretty heavily. And so anyway, you should see a lot more information in the next few days.
Well, very good. Do people have to sign up for this, or what are you thinking is going to happen?
We'll send out a survey about, to get a pulse of how many people want to attend. The club won't be supplying any food, but we'll supply water, and we'll have porta potties out there based on our experience. But if folks want to do potluck, we'll just collect information that way, and then people will ask you to register. So that if you're going to be an early leaver, or we'll park you in a way where you can get out pretty earlier, and then if you're going to be a late leaver, and then if you're planning to stay overnight. So
Okay. Okay, so the 1687 gas reimbursement was already covered. So let's go to infrastructure and legal. Si, do you have anything?
Yeah, on the 1687, so part of the thing that we're going to incorporate for the reimbursement is Robert and I will hand out forms to the individuals who show up out there, and it'll be the individual's responsibility to fill out the form and send it into the treasurer to ask for reimbursement. Just finished the form tonight. We'll get that out to everybody. Well, we'll get it out to the participants at the March 8th, and we'll go from there.
Sounds good. Thank you. So other business. Does anyone have any other business to bring to the club today?
I have something of interest. I don't know if the club would be interested or an individual would be interested, but I've discovered through a real estate broker that there is a 1 acre parcel just on the other side of 36 that's available for sale.
Well, that is interesting.
And that's what I thought too. I looked at it. It is not cleared by Google satellite. It appears to be heavily brushed or heavily treed. I've got the longitude, latitude. It doesn't have an address, but I have the longitude and latitude for it if anybody's interested.
Okay. Thank you, Sam.
You bet.
Any other items to raise on tonight's call? Okay. Bill, you want to tell us about the next month's presenter?
Yeah, so I had originally had I was originally in touch with Dr. Jeff Bauer, who's actually the lead scientist with the Event Horizon Telescope, and he got back to me and said, you know, I think maybe I need to be a little more realistic about my schedule. He realized he was maybe overloading himself maybe a little bit too much. So he recommended Dr. Anatua, and pretty excited about that. He's as you can read here, he's involved with the Event Horizon Telescope, and yeah, pretty excited about this.
Another good presenter. You've done very well this year, including Sarah. She did a great job.
Yeah, thank you.
All right. So thanks everyone for participating in tonight's call. I'm glad you stayed comfortable in your own home. And instead of calling for a vote, I think I'm just going to vote. Have you vote with me exiting this Zoom meeting.
Sounds good. See you guys.
All right.
Have a great evening, everybody.
Clear skies, man.
You.
Oh,
Bye.
for those that usually go, I will not be going to the social club tonight.
Oh, darn.
Good night, all.
All right.
Nice
Nice meeting, guys. Thanks.
Bye-bye.